students, as we are go through the explanations of the reaction, today we are going to see the nitration. How do we get nitrative derivative of aniline from this question? Okay, now aniline combined with concentrated sulfuric acid and nitric acid, that nitrating mixture at 288 Kelvin, you are getting ortho, meta and para derivative of nitrating compound you are getting. Okay, generally ortho and para derivatives only will be getting because lone pair of electrons on nitrogen that is involving for the resonance in that benzene. So naturally the negative charge takes place in ortho and para position only. So electrophiles will prefer to sit with ortho and para position. So you know very well. But here in this point here meta nitrating compound also it's coming. How is it possible? Here aniline combined with the concentrated sulfuric acid. So when concentrated sulfuric acid reacts with the aniline, you will get anilinium ion. So anilinium ion, it is a meta directing group. So that is what we are getting, meta derivative of nitrating compound. Let us go for the reaction so that you will come to know very clearly. So this is aniline NH2 combined with concentrated HNO3 plus concentrated H2SO4 at 288 Kelvin. What is the product you will get it? You will get aniline with orthonitroaniline and metanitroaniline NH2, here NO2 and here paranitroaniline. Here aniline, this is paranitroaniline. The percentage they have given, it is 2% only orthonitroaniline and here 51 percentage and here 47 percentage. Okay, now this is what it is, here 3 and here what it is. You are getting ortho, meta, para. How do we get para? I just mentioned here. This aniline combined with concentrated sulfuric acid, that proton HSO4, that H plus is there, no? So that is combined with aniline. So NH3 formation. So anilinium ion formation takes place. So anilinium ion always go for meta directing group. So that is what you have got it. Okay, now generally I wanted to mention one more question here. Why acetylation takes place while nitration? Generally, acetylation will be available for nitration as we are going for the para-nitro, what it is, amino of aryl compound. Okay, how do we go for it? So here, generally here what it is, aniline combined NH2, this is aniline combined with acetic anhydride. What is it, acetic anhydride? CH3CO, here CH3CO, both connected to get O. You know how do we get acetic anhydride? Okay, I'll tell you. CH3COOH, this is acetic acid and one more combined with another CH3 COOH. So these, what happened? The water has removed while heating. So what happened here also? Here also CO it is available. Here also CO it is available. Both connected together. So removal of water. So removal of water, acetic anhydride, it's forming. Generally anhydride means removal of water only. Okay, CH3CO and then CH3 CO, both connected O. So this is the way we got what it is. Oh, can you, is it visible? Yes. Okay. So this is the way we are getting acetic anhydride. So aniline reacts with the acetic anhydride. You are getting what it is as we have gone through that long last video. So what happened here? In this hydrogen, one hydrogen active hydrogen, no? So this hydrogen combined with this, you will get CH3COOH. So you will get CH3COOH. In the presence of what it is? Pyridine. That is very important word. If you are not using that pyridine, what will happen? That instead of pyridine, if you get aluminum chloride, you will get the salt formation. So please remember that as I mentioned. Okay. Now here what happened? Aniline. Yeah, okay. I hope you're clear with that. Okay, let us go for that. Here aniline. Here NH. C double bond O, CH3, acetanilide or anilide. Okay, this derivative combined with this mixture of nitrating mixture, you are getting amide compound of nitro derivative. Okay, now let us go for that point. Directly we cannot get that nitro derivative of amino group. Okay, this undergoes this reaction first. It has to aniline reacts with acetic anhydride in the presence of pyridine, and you are getting acetanilide. Okay, acetanilide, then only it will go for nitrating mixture. You know, to protect amino group only, we are going around the neck. Okay, now that is what they mentioned. Why acetylation takes place while nitration? So nitration takes place means first and foremost it has to go for acetylation first step. Then only it will go for nitration. Why? To protect the amino group. That is the reason. Okay, now let us go for this. This is the first step. Now let us go for the second step. This is acetanilide. Acetanilide. This is NH. C double bond O, CH3, and combined with what it is concentrated, HNO3 in the presence of concentrated H2SO4 at 288 Kelvin. Now what happened here? You will get para derivative only. Here you will get para derivative. In our last video also I mentioned very clearly why do we get para derivative, because the resonance takes place in that amide group only. The resonance will not come to that benzene group. And one more thing, amide group, it is very less reactive than amino group. Those 2 points I mentioned. So here what happened? NH, C double bond O, CH3, and here NO2. Okay, now third step. This is the second step. No, now third step. What happened? This amide group of nitro derivative. This is amide group of nitro derivative NH C double bond O, CH3, right? And here NO2. I just mentioned, no, this undergoes for that hydrolysis process H2O. So H2O means H plus and OH minus. So what happened here? This point here, H plus, which will go and attach with that hydrogen. Okay, now other than that, OH minus ion which will go and attach with C double bond O. So what happened here? NH2 and CH3 COOH. So CH3COOH, what it is? Acetic acid, and this is aniline, and this is very important what it is. Nitro group. What nitro group? Para derivative of nitro compound we are getting. So aniline cannot go for direct nitro compound unless it has to go by acetylation. Why do we go for acetylation while nitration? Means that to protect amino group, only we are undergoing for this process. So first step, second step, and the third step. This is a 3 mark question for nitration. How do we get nitrative derivative from aniline? Okay, this is very important question. Hope you're clear with this point of nitration. It's very important 3 mark question. These are the three steps. So first step, what it is, aniline combined with acetic anhydride. You are getting what it is, acetamide of aniline group you are getting. So that is combined with nitrating mixture. You are getting nitrative derivative of amide group along with the benzene you are getting. Then again, this goes by what it is, hydrolysis process. Then you are getting amino derivative of nitrating compound you are getting. That is what it is, paranitrative group. Hope you're clear with this. Okay, let us go for the sulfonation. The next one more important question, sulfonation, 3 mark question. Number of times they asked, explain about sulfonation from aniline. Okay, let us go for that for the explanation. Here NH2 combined with benzene ring. So this is aniline combined with the concentrated H2SO4, and you are heating 453 to 473 Kelvin. So what is the product you will get it? You will get the intermediate compound at first. So this is anilinium NH3 HSO4. Anilinium hydrogen sulfate formation you are getting. Anilinium. Anilinium hydrogen sulfate. Okay, now what happened? Again, we are heating the same temperature and we are adding concentrated sulfuric acid also. So you are getting the main sulfoanilic acid formation you are getting. That is the main product of sulfonation. Here aniline NH2 and here SO3H. Sulfoanilic acid formation we are getting. Okay, sulfoanilic acid. Okay, here one interesting question I wanted to mention. Here, what do you mean by Zwitter ion? So the internal formation takes place from the compound. So that means a salt formation takes place in the same compound. So that is called Zwitter ion. Internal transformation of ions takes place to form a salt formation is called Zwitter ion. Okay, let us go for that. From here only I am taking that example. Here what is it? Sulfonilic acid, no? NH2. Here SO3H. Okay, now what happened? Internal transformation of ion. This hydrogen H plus ion which is going over here. So what happened here? You will get it NH3. So when NH3 forms means here a positive charge. So when H plus ion it is donated means here SO3 minus. So that internal transformation of ions takes place. So that is called Zwitter ion. So what do you mean by Zwitter ion? Zwitter in the German word, Zwitter means it is a hybrid. So in that there is what it is, hybridization formation, like a hybrid mixing. So it is internal transformation of ions takes place to form a salt formation. So that is what we can say it is a Zwitter ion. Number of times, 2 more question. They are asking very simple, in the compound ion exchanging in between the compounds only to form a salt formation. It's called the Zwitter ion. So this is sulfur anilic acid, whereas here it is anilinium sulfite. So this is salt formation. This is acid and this is salt, and this is like reversible. Okay, it can come back to the original, and that is called sulfonilic acid. Hope you're clear with this Zwitter ion and the sulfonation. From this only you will collect the 2 questions. Hope you're clear with this sulfonation and the Zwitter ion. Next, one more important and interesting question, how to prepare diazonium salt or how to convert primary aromatic primary amine into diazonium salt. Actually, this is a 2 steps process. Already we have gone through in haloalkane, haloarine part only. We have gone through that. Okay, come on, let us go for that. First and foremost, we have to prepare that nitrous acid, freshly prepared nitrous acid that will react with aniline, that is aromatic primary amine. Then you will get the diazonium salt. Come on, let us go for the first one. This is what it is. Sodium nitrite we have taken along with HCl. You will get what it is, nitrous acid, HNO2 plus NaCl. Okay. Now this nitrous acid along with the dilute HCl, it reacts with what it is? Aniline. So this is aniline. Here NH2. NH2 along with HNO2 with cooling of HCl at 273 to 278 Kelvin. Okay, now here the reaction takes place. So here one small rearrangement for the ONOH. For this only, I just put it like this way for that what it is to get that idea. Now here what it is, HCl, the same compound only. I just put it like this way for you to get that idea. Okay, now what happened? The reaction takes place. So reaction what happened? Here H2O and here also H2O, right? You will get H2O and H2O. So what happened here? One N and here one N and here Cl. So what is the product we are getting? We want that product only, no? What is the product? Diazonium salt. Here N, double bond. Okay, here this is actually bond broken now. So here N, double bond N and Cl. So this is plus and minus. So diazonium salt, azo means two things. Okay, diazo, di. Okay, so this is diazonium diazonium salt. Okay, so this is the way we are preparing this. Okay, hope you're clear with this idea. Okay, now generally aliphatic diazonium salts are not stable, whereas aromatic diazonium salts are stable. Why? Because aromatic diazonium salts are involving in the resonance. That is the reason aromatic diazonium salts are stable. Come on, let us go for that to identify resonance structure of diazonium salt. It is very simple. Let us go for it. Now this is what it is. Diazonium salt. Okay, N triple bond N. Okay, N triple bond N only, that is attached with benzene. Okay, now what happened here? This bond which is going to shift over here. So automatically this bond will be, already two lone pair of electrons are available. So when this bond shifted over here, this will become a positive charge and this will become a negative charge. Okay, now double headed arrow for the resonance point only. Okay, now the next point, what happened here? Double bond here, nitrogen here positive charge, here also double bond, but the bond shift. So when the bond shift, what happened? The two lone pair of electrons will be available here, one lone pair of electron and two lone pair of electron, because the bond shifted here. Okay, here negative charge and here what happened? Here positive charge you will be taking, because the bond shifted over here. So bond donated means automatically you will get the positive charge. Okay, now what happened? This bond goes over here. So automatically you will get the positive charge here. Now the next one, what happened? The same thing. So here double bond, first we'll finish it up the top. N, here positive charge, double bond, here minus charge, two lone pairs of electrons, and here positive charge. So the bond goes over here, no? So you will get it here and here, because this bond goes over here. So automatically what happened? This positive charge will come under here. Okay, so you will get the positive charge here and here, like ortho meta para, like. Okay, now the next point here. Now what happened? This will go over here. So automatically you will get the positive charge over here. So you will get double bond, N, here positive charge, here also double bond, here two lone pairs of electrons, minus charge. So here and here. Okay, this goes over here, no? So here automatically positive charge is there, no? So this bond comes over here. So this bond comes over here means automatically this point just bring it over here. So here what happened, like this. Here N triple bond. So the bond comes back to here. Okay, so here N triple bond N. Only thing here, see that bond here starts from here 1, 2, 3, like, but here it is 1, 2, 3, like that it will be. Hope you're clear with the resonance structure of that diazonium salt. Okay, now we are going to see what are the chemical reactions takes place, the main point of naming reactions. Let us go and analyze with a complete idea, and conversion point also we will go for it. Yes. Diazonium salt only, it's very important topic. Okay, already we have gone through in that allo arraign part also in our organic chapters. Okay, but here also they mention it's very very important topic. Number of questions will be available in this part. Okay, now what are the two categories of the diazonium salt? Reaction involving removal of diazo group, reaction involving retention of diazo group. Removal of diazo group. So diazo group will be completely erased out. So that is a removal of diazo group. Okay, so what are the reactions can be involved in that? Sandmeyer's reaction, Gattermann's reaction, Schemann's reaction. So these are the three important naming reactions which is involved in that removal of diazo group. Come on, let us go for that first one. Sandmeyer's Sandmeyer's reaction. So, what are the components are available for Sandmeyer's reaction? So, of course, this is what it is, a diazonium chloride, and along with that, what it is? Cuprous chloride, Cu2Cl2 along with HCl. Okay, now what you will get it? That is the first one, diazonium chloride, N2 N2Cl. This is a salt, no? So N2Cl. Okay, this is combined with Cu2Cl2 along with HCl. Okay, so what you will get it? So removal of diazo group, right? So automatically you will get chloride ion which is attached over here. So naturally N2 will be out. Okay, diazo group, that nitrogen N2 will be out. So this is a Sandmeyer's reaction. One more reaction also is available for Sandmeyer's reaction. Cuprous cyanide also it will be available. Okay, cuprous cyanide. Here azo groups N2Cl, N2 plus Cl minus. Okay, now here cuprous cyanide CuCN bar HCl. Okay, so what you will get? You will get that respective compound cyanobenzene CN. Okay, Cn plus N2 plus Cu2Cl2. Here cuprous chloride it will convert. Okay, now here, okay, yes. These are the two reactions. Suppose if they are asking how to convert cyanobenzene from what it is, diazonium chloride. If they are asking such kind of question, you are able to answer with that Sandmeyer's reaction. Now we are going for that Gattermann's reaction. What is the difference between Sandmeyer's reaction and Gattermann's reaction? Here they are using cuprous chloride along with HCl. Whereas here Gattermann's reaction, copper powder with HCl. That's all. Okay, now the next one, what it is? Gattermann's reaction. Is it visible? Yes. Gattermann's reaction. Okay, so Gattermann's reaction, it's very simple. The same diazonium chloride only. Diazonium chloride N2Cl. This is a salt formation. Okay, along with that, what it is? Copper powder with HCl. So copper powder with HCl, what it is? You will get it the same chlorobenzene. Removal of diazo group Cl plus N2. That's all. Okay, now the next one, it is Schemann's reaction. Hope you're clear with the Sandmeyer's reactions and the Gattermann's reaction. These are the two reactions or naming reaction and very important. What is the difference between Sandmeyer's reaction and Gattermann's reaction if they are asking? I hope you are able to answer for it. Come on, next one, what it is? The next one, it is Schemann's reaction. These three reaction comes under what it is? Removal of diazo group. Okay, Schemann's reaction. Okay, now here also diazonium chloride N2Cl along with what it is? Hydrofluoroboric acid HbF4. Okay, now what happened? This completely remove that what it is. Diazo group, you will get fluorobenzene. What you will get? Fluorobenzene. Here, fluoro compound it is there, no fluorobenzene. Okay, then N2, it's a natural, and here what you will get? HCl and BF3. You will get BF3. Why? Because one F has gone over here, the other three. BF3. This hydrogen combined with HCl, you will get that HCl. So this is fluorobenzene and this is what it is, hydrofluoroboric acid. Hope you're clear with this. So these are the three reactions for the removal of diazo group. Okay, suppose if they are asking how to get that idea about the removal of diazo group reactions. If they are asking such kind of question, I hope you are able to answer for this. Now, the next interesting question, how do we get these compounds from diazonium chloride? Iodobenzene, benzene, phenol and nitrobenzene. These are also belongs to what it is, removal of diazo group. That is what I just bring it together. Okay, now first and foremost what it is? Diazonium chloride. Here diazonium chloride, here N2 Cl minus N2 plus because it's a salt, no? Diazonium salt. Okay, this reacts with that what it is. Now here the first one iodobenzene. First one what it is? Iodobenzene they have given. So that means Ki. Potassium iodide if it reacts, you will get what it is? Iodobenzene. I just put it here iodobenzene. That is the answer, right? Okay. So here I plus N2, of course, removal of diazo group plus KCl, the Cl. Okay, so this is the first one, iodobenzene. The second one, what it is? Benzene. So for that, mild reducing reaction. So mild reducing reagent, we just take it H3PO2. So hypophosphorus acid. Let us go for it. So you will get what it is? Benzene. You will get benzene here. Yeah, this is benzene only. And here what it is? H3PO3 orthophosphoric acid and N2 plus HCl. Okay, now this HCl. Okay, one more thing also. This is benzene. This is the second answer. And one more thing also. Ethyl alcohol CH3, CH2, OH. So suppose if it reacts, this diazonium chloride reacts with ethyl alcohol, you will get that same compound benzene only. And next one, what it is? CH3 CHO, aldehyde, acetaldehyde plus N2 plus HCl. So these are the two reactant can give that benzene. So this also I just mentioned too because the answer, the second answer it is benzene only. Now third answer what it is? Phenol. Phenol what? How do we get it? This is water hydrolysis H2O, H plus and OH minus. So how do we go for it? Here you will get that phenol compound. Is it visible? Yes. Okay, OH plus N2 plus what it is? HCl. Okay. Now H, this OH which will go and attach over there, N2 and HCl, HCl. You will get, this is a phenol. Hope you're understanding the structure of that name. This is iodobenzene, benzene, and this also benzene. How do we get it? This is from ethyl alcohol along with the diazonium chloride. And the next one, what it is? Hydrolysis, so that we are getting phenol. Then the last one, nitrobenzene. Nitrobenzene actually two steps reaction. You know what are the things to be noted? Here diazonium chloride combined with hydrofluoroboric acid. Then you will get that salt formation along with sodium nitrate. It will react. So you will get the nitrobenzene. Come on, we'll go for that reaction. Hope you're clear with this. All these reactions. Okay, now diazonium chloride. This is diazonium chloride. This is N2 N2Cl minus N2 plus combined with first one HbF4 hydrogen fluoroborate. Okay, now you are getting diazonium. This is N2 will be there as it is diazonium BF4 diazonium fluoroborate. You will get it plus HCl. Okay, diazonium fluoroborate. This is N2BF4. It's called diazonium. Diazonium fluoroborate. Tetrafluoro. Tetrafluoro because 4 it is there, no? Tetrafluoroborate. Tetrafluoroborate ion. Okay, now this is plus and this is minus. Okay, this combined with NaNO2, sodium nitrate. If you heat, you will get what it is? Nitrobenzene. The main product, major product, we will get it NO2. This is nitrobenzene and NaBF4 and what it is remaining, the main azo group removal, no? N2. N2, we got it. Okay. So the azo group removal, these are all comes under azo group, removal of azo group. Okay. So they may ask the question, can you give two examples of removal of azo group from diazonium salt? Such kind of questions you may expect. Hope you're clear all this. These are the 7 important points to be noted for the reaction involving removal of diazonium group. Okay, so next class we are going to see retention of diazonium group. Hope you're clear all this and thanks for your support. Thanks for watching.